How do cranes lift massive loads without falling? Have you ever looked at a construction crane lifting tons of steel, concrete, or machinery high above the ground and wondered, how does it not simply tip over? Cranes can lift incredibly heavy loads while remaining stable because they are carefully designed around one fundamental principle: balance. A crane is not just a giant machine with a powerful motor. Every part of its structure is engineered to control forces, distribute weight, and keep the center of gravity in a safe position. Let's start with the base. Tower cranes are usually anchored to a massive concrete foundation. This foundation connects the crane to the ground and provides the stability needed to resist the enormous forces created when a heavy load is lifted and moved. At the top of the tower is the horizontal arm, called the jib. One side of the jib carries the load, while the opposite side contains a counterweight. These counterweights are extremely important because they balance the weight being lifted. Imagine holding a heavy object with your arm extended. The farther the object is from your body, the harder it is to keep your balance. A crane experiences the same effect. Engineers call this rotational force torque. The heavier the load, and the farther it is from the center of the crane, the greater the torque. That's why cranes have strict load limits. A crane might be able to lift a huge load close to the tower, but a much smaller load when the load is positioned at the end of the jib. This is also why crane operators must carefully follow the machine's load chart. The chart shows how much weight the crane can safely lift at different distances and configurations. But counterweights aren't the only thing keeping a crane upright. The crane's tower itself is designed to handle compression, tension, bending, and twisting forces. Its steel sections form a rigid structure that transfers forces down toward the foundation. The lifting system is also carefully engineered. Powerful electric motors drive drums and cables that raise and lower the load. Multiple sections of cable can be used through pulleys, allowing the system to distribute the load and increase lifting capacity. Mobile cranes work differently. Instead of being permanently anchored to a foundation, they use heavy chassis, counterweights, and outriggers. Outriggers extend outward from the vehicle and create a much wider support area. When a mobile crane is lifting a heavy object, those outriggers transfer forces into the ground and dramatically increase stability. The ground itself must also be strong enough to support the pressure created by the crane. Modern cranes also use sophisticated safety systems. Sensors can monitor the load, boom angle, wind conditions, and other important parameters. If the crane approaches an unsafe operating condition, warning systems can alert the operator or restrict certain movements. Wind is another major challenge, especially for tower cranes operating hundreds of feet above the ground. Strong winds can push against the boom and the suspended load, creating additional forces. Engineers therefore consider wind resistance when designing and operating cranes. So, what is the secret behind a crane's incredible lifting ability? It's not just raw power. It's physics, engineering, balance, counterweights, structural strength, and precise calculations working together. Every kilogram matters. Every meter of distance matters. And every movement must remain within carefully calculated safety limits. That's how these enormous machines can lift loads weighing several tons without falling. They don't defeat gravity. They are engineered to work with it.